Name a segment that is parallel to the given segment. If you'll notice, DF is a mid-segment because it connects to midpoint, so it's parallel to CA. BD is a mid-segment because it's connected to the midpoints of the sides of a triangle. It's parallel to AE. And likewise, BF is a mid-segment because it's connected to the midpoints of the sides of a triangle, so it is parallel to CE. So, the segment that's parallel to BD would be segment AE. The segment parallel to CA would be DF. The segment parallel to FE, FE is contained by this whole side, so it would be BD. Parallel to FB, FB is here, so it would be CE. Parallel to CD, again, that's part of CE, so it would be BF. And parallel to DF would be CA. Understand that each one of these, you could have written this in a different order. You could have said EA. So long as these 2 points were used, it doesn't matter the order that they're in. Since these are midpoints, each one of these segments are a mid-segment. And since they're midpoints, it would cut this side in half. So where this 25 is, this would be 12.5 and 12.5. When it cuts this 30 in half, each of these would be 15. And where it cut this 44 in half, each of these would be 22. The mid segment is half of the third side. This would be 22. Since this was 15, these would be 15. And the remaining one here would be 12.5. No matter which piece they're asking me for, I should be able to find it now, and it should have a value in it. Y to K, 22. L to K, 12.5. Y to L, 15. J to K, 15. J to L, 22. K to L, 12.5. Again, I can see that the segment that's here is a mid-segment because it's connecting the midpoints. If I take the mid-segment and multiply it by 2, it will be equal to the side that it's parallel to, that third side of the triangle. This would give me 8x minus 20 is equal to 6x plus 4. Subtracting 6x from both sides, I have 2x minus 20 equals 4. Adding 20, I have 2x equals 24, which means x is equal to 12. Likewise, I end up with the same thing in number 14, where this 21 is a mid segment, so I can take the mid segment and multiply it by 2, and it is equal to that third side. This would be 42 is equal to 5x, and I would divide both sides by 5. And when I take 42 and divide it by 5, I could leave it as a fraction, or I could change that into a decimal, which would be 8.4. Certainly either of these would be acceptable. Number 15, name the point of concurrency of the angle bisectors. If I trace out the angle bisector, it would be this one, and this one, and the point where they intersect is that point of concurrency, which would be Z. an angle bisector here. The angle bisector is here, and their point of concurrency is X. Because EG is a perpendicular bisector, and I can see that I have a right angle, this side is congruent to itself. I can see that I have hypotenuse leg, so I know that these two pieces are in fact going to be the same. So I have 4x minus 12 equals 3x plus 1. If I subtract 3x from both sides, then I would have x minus 12 is equal to 1. And if I add 12 to both sides, I'd have x equals 13. But they asked for FD, so I have to plug that 13 back in. 3 times 13 is 39, plus 1 is 40. So each piece of this segment is 40 units long. So FD is a total of 80. Now, they didn't mark this in this picture, but in order to do this problem, this would have to be marked as 90 degrees because they're showing this is an angle bisector, and the distance from any point on the angle bisector to the side of the angle is congruent. So 7x is equal to 3x plus 2. Subtracting 3x from both sides, I have 4x is equal to 2, and dividing by 4, I get x equals either 1/2 or 0.5. If I plug that back in, because they're looking for IU, 7 times 1/2, you could leave it as 7/2 or 3.5. Because MP and MW are the same distance from the sides of the triangle, then I know that YM is an angle bisector. It cuts this angle into two congruent pieces. So 6x minus 1 is equal to 2x plus 5. Solving for x, I'm going to subtract 2x. 4x minus 1 is equal to 5. Adding 1, 4x is equal to 6, and then dividing by 4. X is equal to 3 over 2, or 1.5. Again, they're looking for this angle, PYW, so I do have to plug that back in. 2 times 1.5 is 3. 3 plus 5 is 8. This angle is 8, which means this angle is also 8, so the whole angle is 16. Here they're asking for TP. I'm sure they meant to ask for something else, but TP is 9. If they were looking for LT, I know that this is a perpendicular bisector. I can see that it hit it at 90 degrees. So it should be the same distance from T to P as it is from T to L. Because they've marked these two as being congruent, I know that 7x plus 2 is equal to 2x plus 12. Subtracting 2x from both sides, I have 5x plus 2 is equal to 12. Subtracting 2, 5x equals 10, so x is equal to 2. They did ask for OU, so I have to plug it back in. 7 times 2 plus 2 is 16. Each one of these pieces is 16, so the whole thing is 32. Because this is a perpendicular bisector, I know the distance from K to H and the distance from K to N are the same. So 5x is equal to x plus 12. Subtracting x, 4x is equal to 12. Dividing by 4, x is equal to 3. If I plug it back in, 3 plus 12 is 15. Because n to I and n to z are the same distance from the side, this is an angle bisector, so this angle would be 38 degrees. IJZ, then, this whole angle would be the 38 plus 38, which is 76 degrees. Again, they've marked this as being an angle bisector, so even if they hadn't put this little mark here showing that these were congruent, I know that the distance to the sides were the same. So 7x should be equal to 3x plus 16. Subtracting 3x, 4x is equal to 16. Dividing by 4, x is equal to 4. If I plug that back in, this is going to come up to 7 times 4, which is 28, and that is what they're looking for. RQ is 28. Because M to Z and P to Z are the same distance, they're the same length from the sides, same distance to the sides of the angle, then this is an angle bisector, so x plus 9 must be equal to 2x minus 1. Subtracting x, I have 9 equals x minus 1, and then adding 1, I get x equals 10. If I plug that back in, this angle is going to be 19. It means this angle is also 19. They are looking for MFP. They're looking for the whole thing being put together. 19 plus 19 is 38. When you have a centroid, I'm just going to go ahead and put these pieces in here. Again, it's important to know your vocabulary. Centroid is the point of concurrency of our medians. This is 8. DH is 5. And they said SM is 21. And we have to kind of remember that there is this relationship in a triangle that has a centroid, that whatever the value is from the vertex to the centroid, it is twice as big as the centroid to the side, and then the whole thing is actually 3x. And if you remember this relationship, you can find any of these pieces. If this one's 8, the distance from the vertex to the centroid has to be twice as big, would make this 16. 16 and 8 is a total of 24, so the whole segment is 24. If the bottom part from the centroid to the side is 5, from the centroid to the vertex is twice as big, this would be 10, making the whole thing from the vertex to the side 15. If they give you the whole side, it says then that 3x is 21, so x would be 7 by dividing by 3, and the distance then from the vertex to the centroid would be twice as much. This would be 14. And I should now be able to fill in the blanks. From S to H, 14. From H to M, 7. From T to H, 10. H to R, 16. From T all the way to D, the whole thing is 15. From E all the way to R, the whole thing is 24. Here's another problem with a centroid. I know that if it's a centroid, it is connecting the vertices to the midpoints of the sides. I know that in this particular problem, I don't need that. They did tell me that MZ was 20. They told me that from Y to I, the whole segment was 15, and that N to Z was 11. If N to Z is 11, then from the vertex to the centroid is twice as big. This would be 22. The whole segment then would be 22 plus 11, which is 33. If the vertex to the centroid is 20, then the piece on the remaining going from the vertex to the side is half as big. It's going to be 10. The whole segment is 30. Remember, there's kind of a special relationship. The distance from the centroid to the vertex is twice as much as the centroid to the side. The whole thing then is 3x. You divide each side by 3, so the distance from the centroid to the side would be 5. The distance from the vertex to the centroid would then be 10. All the pieces are filled in. I should be able to just go down my list. From Z to R, 10. From Y to Z, 5. M to R, the whole segment, 30. From Z to V, 22. From N to V, the whole segment, 33. And from I to Z is 10. You should know your vocabulary. The point of congruencies of the perpendicular bisectors is called the circumcenter. These points are equal distance to the vertices of the triangle. The point of concurrency of the angle bisectors is called the incenter. These points are equal distance to the sides of the triangle. The point of concurrency of the medians is called a centroid. These points create a 2-to-1 relationship with the parts of the medians. The distance from the centroid to the vertice is twice as big as the centroid to the other side. The point of concurrency of the altitudes is called an orthocenter, and there is really nothing special that we learn about that triangle, except because their altitudes, they make 90-degree angles.